So let's finish up section 5.3. Some ionic compounds have polyatomic ions in them. Now you've memorized some of those. I gave them to you at the beginning. Things like nitrate and sulfate. Polyatomic means it has more than one atom in it. So sulfate is SO4 with a 2- charge. It's an ion that has more than one atom in it. So these act as groups, and if we have more than one of them in a formula, we have to indicate that by using parentheses. So they're kind of like bundle packs. You go to Costco and you buy a Wii, and you can't just buy the Wii like you could at Walmart, right? Because it's going to come with an extra controller and 2 games or something, and it's going to be all bundled together, and that's all they sell. You can't buy them individual pieces. So a polyatomic ion is like a deal at Costco. It comes shrink wrapped together, and it comes in units. Okay, so sulfate is 1 sulfur and 4 oxygens. You can't just get the sulfur by itself. And so when you have those in an ionic compound and there's more than one, you have to draw the shrink wrap, the parentheses around it, and put how many packages you have on the outside. So here's an example for magnesium nitrate. So here we have the symbol for magnesium, and here we have the nitrate group, NO3, and there are 2 of them. And so we've got parentheses like shrink wrap, and then on the outside is the number of those units that we have. Okay, if there's only one of them, we don't need to draw the parentheses and we don't put a number 1. But if you have more than one polyatomic ion, you have to put parentheses around it. Any questions about that? So let's look at these formulas and figure out how many atoms of each element, each type of element are in here. And so this is just understanding what a chemical formula means. So K2SO4, what 3 elements are present? Potassium and sulfur. So potassium and sulfur and oxygen. Okay, so just list the element symbols. How many potassium atoms are in that formula? 2. How many sulfurs? 1. How many oxygens? 4. Okay, that wasn't too bad, was it? Let's look at this one. Al2SO4 3. And that's how you would read that. What elements are present in this formula? We've got aluminum and sulfur and oxygen. How many aluminums? 2. How many sulfurs? 3. There's 3 of these bundle packs. Each bundle pack has 1 sulfur in it. So there's 3 sulfurs. How many oxygens? 12. Each of those packages has 4 oxygens. You have 3 packages, so you've got 12 oxygens. Okay, so everybody clear on how the parentheses work? You could also think of it as distributing in math, where you take the number on the outside of the parentheses and it multiplies everything on the inside. There are different types of chemical formulas. Empirical formulas are going to give us relative numbers of atoms of each element. Empirical. Empirical means from experiment. A molecular formula gives us the actual number of atoms that are in a molecule. So molecular formula. And structural formulas tell us how those things are connected, typically using lines to show how the atoms in that molecule are connected to each other. We also have molecular models, and these can be useful in helping us to visualize what this might look in 3D. So molecular models give a more 3-dimensional representation. There are ball and stick models where, they represent the atoms as balls and the bonds as sticks. That's why they call them ball and stick models. Space filling models are a more accurate description or representation of what the molecule looks like. So here are some pictures. We had pictures. So this is a molecular formula. It tells us in one molecule we have one carbon atom and 4 hydrogen atoms. This is a structural formula because it shows us how those atoms are connected. And you can have one molecular formula and actually have two different structural formulas. You can have two compounds that have the same molecular formula. Their atoms are just connected differently, and that affects their properties. This is the ball and stick model. So here, this black ball represents the carbon, and we've got hydrogens around it. This gives us a clue about the shape, but it doesn't. Molecules don't really look like, Tinker Toy creations. This is more like what a molecule actually looks like. So this is space filling, and so we'll see those sometimes, and that's what that means. I'm not going to make you draw them or anything.